Hello, everybody. Welcome to our first day of notes for Algebra 2A. We're going to go over some vocabulary words today, and you'll watch a second video as well. But for now, we're just going to talk about these vocab words. Make sure that my name's on my packet, and I'm going to go here. Now, you should be following along with your copy, or you can take your own notes on a piece of paper if you'd like. It's up to you. I'm going to ask that you just pause the video for a second and just read over these vocabulary words. We're going to talk about this global versus local situation in a second, but I want you to just read these words on your own. Now that you've read those words, a lot of these should be familiar to you. If they're not, you should reach out to me and make sure that you get some clarification. I'm going to just start applying them. I'm not going to go over every word in detail with you. And you will either pick up on it as we apply it, or you can ask me a question about it later. All right, but one concept that we do need to talk about is global versus local, and we usually apply those to maximums and minimums, okay? A local maximum or minimum, depending on if you're thinking about a peak or a valley, right, of a graph, is an area where it's the smallest or largest value around. It's the most extreme around. I like to think of that as like Mount Washington, right? Mount Washington isn't the highest point on Earth, but it's the highest point around here, right? It's our local maximum. It's our local extreme, right? Whereas a global maximum or minimum is the most extreme anywhere. So I like to think of it as Mount Everest. Right, so a local max or min might look something like this. If we have a graph that just like kind of bounces up and down, these guys right here, right? Whereas a global maximum or minimum would kind of do something like this, right? And like this might be the highest point. Ooh. And this might be the highest point. Like right there. And we can have some local mins in there and some local maxes, but it's not the global. That's our global, right? All right. All right, so I'm gonna practice just using these set of words on these graphs down at the bottom, okay? Okay, so I kind of pre-set up my page here. Before I go over any of these vocab words, and how we apply them to a graph here, I want to talk about something called interval notation. It's how we're going to write answers. You may have used inequalities in the past to talk about when things are increasing and decreasing and all that good stuff, but we're going to use what's called interval notation. It's a little bit more formal, okay? And some of you may have used it before. And it's just when we put some numbers in a set of parentheses or brackets, and we can mix parentheses and brackets when we use interval notation. That's okay. And I have two numbers in there. One's going to be the start, and one's going to be the end. So if something increases between like 6 and 5, or 5 and 6, excuse me, I would use 5 and 6 as my start and end points. The kind of parentheses you use tells me if it's an excluded value. So for example, if this number was 5, right, it would be all the numbers up to 5, but not including 5. So like 5.0001, 5.0001, etc., but not 5 itself. Whereas this would be included, where it does include the 5. Or 6 in this case, because we said 5 to 6. The vertex of this first graph, right here, that's 2, 1, right? Easy. Axis of symmetry, line that cuts the graph in half, so that's right there, x equals 2. Now the axis of symmetry isn't actually part of the graph. You can kind of think of it as an imaginary line there. I just drew the dotted line to help you visualize it, right? Now the graph is increasing to the right of the vertex, right? This is the part of the graph where if it was like a graph of temperature, the temperature is going up. So that's from 2 on forever. So it's from 2 to infinity. For increasing and decreasing, you always use open brackets. You always use the curved parentheses, right? Whereas decreasing, it's going down on the left side. So it's from negative infinity to 2. Always put your lower number on the left. We don't really have a maximum, right? So that symbol right there just is, it means empty set. It means no answer. And the minimum is 2, 1. And it's a global minimum. Nothing's lower than it. This whole parabola is concave up because it opens upward. So it's concave up from negative infinity to infinity. Concavity can change, and we'll see that in a second. The domain of this graph is all real numbers. You can state all real numbers as negative infinity to infinity or with the all real number sign. It's up to you. Whereas the range of the graph doesn't have, it doesn't go on forever. Remember, range is the set of possible outputs, so it has a lowest output of 1. That's the smallest it can get. Notice I used a square bracket there to indicate that it can get to 1. And then it goes up forever from there. So 1 to infinity. With infinity, you always use an open bracket because it will never actually touch infinity. Infinity is not really a number you can touch. Let's try the second example. The axis of symmetry here. There is no vertex because it's not a parabola, but you can think of these like little guys as turning points or local or global maximum and minimums. We can talk about those in a second. Well, I want to just point out to you that there doesn't really have to be an axis of symmetry, right? That's not something that has to exist. But what I really want to point out to you here is that this graph increases here and here, right? It increases twice, and we have to state that. So we would say from negative infinity to 0 it increases. And we use this U, it's called a union symbol, and that means or in math. We're saying it increases here or here. And we can estimate where this is. Let's call it 1.5. 1.5 to infinity. So it increases from negative infinity to 0 in union with 1.5 to infinity, but it decreases from 0 to 1.5. Just in that middle range, right? It decreases there. We have a local maximum, right? Let's denote these on the graphs. 0, 0 is a local max. And let's call this 1.5 negative 1.5. We're estimating a little bit. Is a local min. Now again, we have something going on here with the concavity. I'm going to erase our highlighting for a second. My concave up part of my graph, the part that opens up, this part definitely looks like it's opening up. It's kind of like we have two parabolas meeting, right? Whereas this part looks like it's opening down. Well, my concavity can change. I am concave up from, let's call that 1, right? From 1 to infinity. Whereas I'm concave down from negative infinity to 1. Your concavity can change as the graph changes. And these are just good words for you to get familiar with as you go further and further into math. Okay, my domain and range here, I kind of just look at this graph. I have an arrow pointing left and an arrow pointing right, so the domain is all real numbers. I have an arrow pointing up, I have an arrow pointing down, so the range is also all real numbers. Okay guys, what I'd like you to do is try that last example yourself. Come in with some questions or things you're unsure about next class, and we'll take care of it from there. Thanks and have a great weekend.